How to classify rocks. To classify means to sort or to group, and when we classify rocks, we mean the term rock to mean a naturally occurring, solid, mass or aggregate of minerals. Rocks can be classified by using three descriptive categories, which are how it formed, its chemical composition, and the minerals included in them, which gives us three classes of rock, which in no particular order are sedimentary, igneous, and metamorphic rocks. Our first group are the sedimentary rocks, which are named because they are made of sediments, so giving us three categories of sedimentary rocks. The first is clastic sedimentary rocks, with clastic meaning bits of older rocks, with clastic sedimentary rocks further categorised by the size of the sediments, from large through to microscopic, and the shape, ranging from rounded through to angular. With examples of clastic sedimentary rocks including conglomerate, with rounded pebbles in a sandier matrix, and breccia, with angular pebbles in a matrix, and sandstone, composed of sand-sized grains, and mudstone, made of mud-sized grains. Our second category of sedimentary rocks are the chemical sedimentary rocks, including limestone, made from calcium carbonate, often full of water-based fossils, and dolostone, a more magnesium carbonate-rich rock type, and evaporite-formed deposits such as gypsum and salts. The third category of sedimentary rocks are the biologic sedimentary rocks, formed from once-living organisms, such as ancient forests and plants making coal, and chert, formed from microscopic plankton that lived in ancient seas. Wow! Our second group of rocks are igneous rocks, which also have two categories based upon where it formed and their chemical composition. Igneous rocks can form in either of two locations, which are below ground and above ground. If formed below ground, the molten rock, called magma, at very hot temperatures, will generally cool very slowly, so the hot magma, as it gradually cools, forming intrusive igneous rocks, and crystallises with large crystals, with granite as a common example. Alternatively, instead of being underground, if the magma breaks the surface, it is known as lava, making it an extrusive igneous rock, leaving the ground at a volcano, the lava cooling much more quickly, so being composed of smaller sized crystals, with basalt as a common example. So igneous rocks can be categorised by both crystal size and the silica content of the rocks, from silica poor, such as gabbro and basalt, to diorite and andesite, to granodiorite and dacite, to the most silica-rich examples of granite and rhyolite. That's amazing! Our third and last group of rocks are metamorphic rocks, which are also crystalline but are not formed in the same way as igneous rocks. Metamorphic rocks can be divided into two categories, they all forming by older rocks being subjected to both heat and pressure, and when these increase, rocks get compressed and crystals will form, sometimes perpendicular to the pressure direction, forming a foliation, so giving us foliated metamorphic rocks, such as slate at lower grades of metamorphism, then schists at higher grades, to gneiss at the highest grades of deformation. Non-foliated metamorphic rocks do not show foliations, with quartzite being formed from older rocks such as sandstone, and marble from older limestones or marbles. A classification of rocks, with sedimentary, igneous, and metamorphic rocks, all categorised into a classification of rocks. Please do watch our video about grain size in sedimentary rocks. Please subscribe to my channel. Bye!